This video will demonstrate the new point-to-multipoint capability that's been added to Path Designer. On my screen, as you can see at the top left, is the Path Designer main form. Behind it is a path loss GR5 map showing a large transportation network or project consisting of 580 sites and 438 paths. It's a sectorized BTS network, and you can see that with the coverage heat map from one BTS which has been plotted here. Many of the sites are CCTV video cameras. What I want to demonstrate to you is how Path Designer interacts with path loss, reading and writing data between the two environments. It allows you, the user, to create GR5 maps with all of the BTS capability, and it can read in the GR5s, again, all the same information back and forth. Now, the reason we would want to have Path Designer involved rather than simply using path loss as a good engineering tool is that Path Designer provides a centralized data management system. It allows you to have all the data in one place and link to many applications: the engineering, the survey, the PCN management, the financial. You can create other types of files for other applications like ArcMap files. We have an extensive equipment database behind it, which is applied into the paths and into the BTSs. And there's a lot of specialized engineering functionality, such as traffic loading calculations, for example. There's a lot of efficiencies in how data is managed and sorted and grouped and displayed and reported. So Path Designer gives you a centralized data location which talks to many applications, a lot of efficiencies, and a lot of specialized functionality. So I'll start now by showing you, for the point-to-multipoint application, the editor within PathLoss and how it's structured and what its fields are very quickly. And then I'll show you the same editor within Path Designer. After that, I'll show you creating a GR5 map out of Path Designer, starting with Path Designer. And lastly, I'll read in a GR5 with all of its data so you can see that it comes into Path Designer. So we'll go into path loss here. Just zoom in on this example BTS, and I'm going to right click on this BTS and go to the base station editor. Now there's multiple forms here, and each BTS has to be individually clicked on to bring up the editor. So I'll click on the base specifications here. This is a form that contains most of the information associated with the BTS site. So on the left section here is the sector. This is sector 1 being displayed. There's the base antenna, the base radio, and the channel information associated with that sector. We can click through different sectors here. In this case, there's 3 sectors that have been defined. You can add sectors by upping the number of sectors in this box here, and then going into the editor and setting it up for all the equipment that you want to set, as well as the azimuths and the down tilts of the antennas. On the right is the CPE, or customer premise equipment definition. This is the template of the equipment that gets applied to customer premise sites which are linked to this BTS, and it includes the antennas, excuse me, the antennas and the radios. There's also transmission lines and a number of other fields that can be set that are specific to the BTS application. There's station data, which is some labels like call signs and so on. There's antenna heights and transmission lines. And there's antenna coupling unit, which is losses on the radio and antenna system. Okay, so now I'll go into Path Designer and show you the BTS Manager here. So under the Site menu, we have a BTS Manager selection, which is new. It brings up a form with all the same parameters that we just looked at. On the left, we have a list of sites. These are all the sites in the system. To the right of that, we have general settings for the selected site, which are associated with the point-to-multipoint BTS application. We have the remote customer premise equipment definition area, and below that we have a base station sector information. So I should point out that we're showing all sites, not just BTSs in this list. The reason for that is that we may want to convert another type of site to a BTS, so we have to have access to it readily. So we would just click on it, we would fill out all the associated fields and save it, and it would become a BTS. What I'll do here is I'll select a BTS that has been set up. It was part of the network you just saw. Um, so when I click on it, the information associated with it is populated into the fields, and it includes the equipment as well as the sector information and of course the other stuff. Now, equipment in the BTS manager, in fact, in all of the Path Designer management, is driven from a master equipment database, a very extensive equipment database that CIC maintains. Um, so in Path Designer, there's an equipment menu with managers for different types of equipment. I'll show you the antenna manager. Now, I haven't put very much data in here. It's easy to load antennas, radios, and lines from the master database, but I've only put in four actually here, antennas, and there's two radios, just to keep it simple for our demonstration. So there's 3 sector antennas here and 1 customer premise equipment antenna. You'll notice that when I click on the customer premise equipment, the specification file area here gets filled out. This is a link to where the file is located. The file is a path loss ASD type file, and it contains all the information about the antenna. Here we have general specifications, the gain, the beam width, and so on. But this ASD file also includes, most importantly, the patterns of the antennas. And I can open it. I'll show you here by clicking and opening. This is the path loss editor, and if I go into the curves here, you can see the azimuth pattern plotted and listed, and here we can also see the elevation pattern. Now, the antenna patterns, when you're doing heat maps, that is coverage maps in the GR5, are absolutely critical. And we'll point out that the elevation pattern in particular is very important, because you may have a BTS that's covering a large area, but you also want to be able to pick up signals from sites close in, so you don't want to just overshoot with your antennas. So the elevation pattern gives you the ability to calculate the signal level that gets to the close in sites, whereas the azimuth pattern tends to influence more the signal level that gets to the far out sites. So that's very critical in this application. Okay, so going back to my BTS manager here, for any particular BTS, we'll start with the remote template here, the remote definition. We select the band that we're working in. That's sort of a pre-filter for equipment. Then we select the radio that we're interested in, then the modulation and the configuration. And then we choose the antenna model from the list of antenna models that are in the manager, and the line model. There's none in this example. And we can set antenna heights and waveguide lengths. And we set up the other parameters, and we save. So that would define the basic parameters of the BTS, not the sectors yet. The sectors are done in the lower portion here. In this example, we have 3 sectors. Anytime I click on a sector in this list, the edit fields above are populated with the values, and I can edit them. I can change values. So as before, I can choose the radio I'm interested in, the modulation, the configuration. I should mention configuration could be things like hot standby, 1+0, 2+0, and so on, even XPIC, although I don't think that applies in a multi-point application. The antennas you can choose here. You can set the heights, the azimuths, and the down tilts, and all this other information that we saw in the other editor. So each of these sectors can be filled out with information, and then just clicking on the save will save that data. We can add a sector by just adding another number here, fill out the edit fields, and click save, and it adds it to the list. And we of course can delete the sector. If we want to have equally spaced antennas, say at 90 degrees, if we had 4 sectors, then we would set the azimuth for the first one, click on symmetrical sectors, and the azimuths of the other sectors will be set. It'll figure out the angle based upon the number of sectors. Okay, so that's kind of the editor here. What I will next show you is the plotting of the GR5. Now, in order to do this in a easy to work with engineering way, we want to create layers. So we want every BTS, or at least what I'm going to demonstrate to you is every BTS and its associated sites and paths on its own layer in the GR5. So the way that I've done that is in the site manager and also in the path manager. I'll show you in a moment. There's a parameter called network ID. This is a general use parameter. You can put anything you want into it. It's just a label on the site. But what I've done is for the sites associated with specific BTSs, I set this parameter to the name of the BTS. And I've sorted them so it's easy to see here. So this group here, as you can see, says Smart Parking 8. That tells me that all of these sites are tied back to the site, which is called Smart Parking 8. And if you look here, you'll see Smart Parking 8 is part of this group, and it is a BTS site. The other sites are RF sites. And as we scan down, you can see other groupings for other BTSs. Um, Now, the same thing is done in the Path Manager. On the left is the network ID, and you can see this group, for example, is all tied to C163. So this is a setup that I've done. It didn't take very long, but it has enormous power in terms of helping us manage the mapping um, within the GR5, and of course for a lot of other applications like reporting and so on, it helps. Now we go into the maps, plot GR5 map menu here. We're going to set up the layers as I've just said. So we choose the user programmable group. A group is a layer in path loss. I'll clear out what's here, and I'm going to select network ID for the sites, and then I'll select it for the paths also. So these are the parameters that will define how the layers are built in the path loss GR5. I then select all sites, and I'm going to do all paths in this example. There's other options. We'll talk about them briefly in a minute. And then I click plot the GR5, and I'm going to replace number 2 here. It takes about 15 seconds to plot this network. As I said, it's 580 sites and 438 paths, so that gives you a kind of a sense of the time to plot, and we'll talk a little bit about the time to read in the file in a minute. Okay, there, it's completed the map. I'm going to turn off the labels to make it easier to see. And I'll bring up the editor for the groups, which is the layers. So these are all the layers that it's created, or Path Designer has created in Path Loss. And each of these, as I said, is associated with a site of groups, a group of sites rather, associated with a specific BTS. And I'll just turn on the one we worked on before, which is CCTV 98 here. So this is the site group. And I'll turn on the path group down here, which is Path Network ID CCTV 98, and click on it. And then we'll just zoom in here a little. So you can see the group that it's created based upon this layering concept. And I can now create the coverage map using the local study. Showing you this illustrates that the patterns that are stored in the ASD file, which Path Loss or Path Designer accesses, can be used for creating this GR5 coverage map. So that's showing you how we create the layered views in Path Loss. I'll close this. I won't show you, but I'll mention quickly, when we plot, we don't necessarily have to do it in the layered way I've shown you. We could select only a specific site. So if we just wanted to see one site, or even one path for that matter with its end sites, we could select them in the managers and just say plot only selected site, or only plot the selected paths. So we have a lot of capability, and we can layer the network in many, many, many ways, and we can put labels on the sites and the paths differently according to our needs. Okay, so lastly what I'll show you is reading in the the GR5. I'm going to start by clearing the equipment and the tool. If I read in a GR5 into a tool that has data, it will add what's coming in to the tool. It'll update, of course, existing sites. So either, or paths for that matter, it'll either update them or add to them if they don't exist. But for the purposes of demonstration, I'll clear out the tool first so you can actually see the data come in. And clear the paths. And I'll just show you quickly the site manager is empty. The BTS manager is empty. And the path manager is empty. So to read it in, we go to the network menu and we read in network GR5 and we browse. I'll bring in the one that we started with initially, this GR5 map, open. This takes about, for this size of a network, it takes about 2 minutes on this computer. Depending upon the computer, it may be faster or slower, but it takes about 2 minutes to bring it in. So I'll pause the video, and when it's complete, I'll show you the result. Okay, so it's finished bringing it into this screen here. It actually hasn't loaded the data into the tool yet. It's brought up an import form showing me what's coming in to give me an opportunity to see the data before it's actually loaded, so I could exit if I wanted or create a report. So you can see the new site coming in, the new sector, and the parameters, the values for the various parameters. And we can open up the fields here to see better. So the antenna height, for example, in this sector is 150. The azimuth is 15. If I scan to the bottom of the list, I can see new paths coming in with their parameters. And of course, the site itself is coming in. Now, as I say, I can stop if I see this is not the right thing. I've done the wrong one. If I want to see the report but not import it, I can stop and show the Excel report, which is essentially this exact data in an Excel format. I can import, or I'll do what I'm going to do now here in this demonstration is import everything, but also show me the report so I have a record of what came in on this import. So it's loading all of the managers with this new data. That the actual data that's being imported has already been loaded into the database. It's available. And the Excel report is ready. It's just taking the time right now to load the views. Okay, and it's finished, and you can see the map, rather not the map, the Excel report here that came in. So with all of this extensive information. If I go back to the manager here and I open, say, the BTS manager, you can see the sites that came in. So all the data is here. Similarly, the paths have been brought in. So that essentially shows you that we can bring in data from the GR5. So that concludes my presentation of this new feature. I'll just stress that the use of Path Designer with PathLoss, as I said, gives you enormous capability in terms of centralized data management, access to many other functionalities such as survey management, PCN management, and so on, as well as links to other types of softwares like creating files for ArcMap. It's very, very efficient, has lots of specialized engineering features, so it's very advantageous to have this connection. I hope this was interesting. Thank you.